Hello, everybody. As we will continue for covering the quick demo for week 6, we had covered already week 1 to 5, and today I'm going to show you week 6 demo. Week 6, that's for both the units, the COIT, the 20261, and the COIT 12206. So Tutorial 6 based on two tasks. The first task is really easy, and you will see that we have in week 2 have used one of those simple topology, the setting one. So we ask you to build a simple topology of one switch and four Linux hosts. Give them IPs and so on. I have removed the IP of one of them, which I'm going to show you now, and let's see what will happen. So what we ask you here, we want to check that what we call it ARP. If you don't know what is ARP, just to go over the lecture, it has more details about that. However, I'm in the lecture video as well. However, it's basic concept that switches, the layer 2 switches, do not understand IP addresses. In short, that PC has an IP 192.168.10.10 and want to communicate with 192.168.10.30. However, the layer 2 switch only understand layer 2 addresses, which is the MAC address. So how we map, we call it mapping. In your term, maybe you call it convert or something, well, it's okay. But the concept, how to match IP to MAC, MAC to IP. We use a protocol, very famous protocol called ARP. The ARP, when the switch receive a MAC address, I don't know how to deal with MAC address. So send a broadcast to every device link except the one it came from, asking, gentlemen, who actually has that IP address, whoever has that IP address, can you send me your MAC address? When the switch received the MAC address, match that one, the IP, with the MAC, with the port. And after that, put the IP aside and keep the MAC and the port. That's it. So from now on, devices, they can communicate with each other through the port and the MAC address only. How we demo something like that? Easy. Let's jump into, I create you as well a screenshot just in case. I know that sometimes I run a little bit quick. So if you want to see what's going on, here it is. I'm going to jump to the PC number, the host 1. And let's see that this is, for example, that's 192.168.10.10. Let's see that if we have any neighbor. There is no neighbor. Really? Yes, let me just clear that so you can guys see that. The command here, nothing. So let's say that the MAC table or the neighboring, because that the host doesn't have a MAC table, the MAC table on the switch, but the neighboring, the cache memory, I don't have any. There is no any temporary neighboring with any. So how to build something like that? I'm going to ping 192.168.10.20, which is the one next to me right away. Here it is. Now I will go back and I will run the IP neighbor show. Now I got one entry. Okay, so what's in that entry? This is 192. I can reach it through the Ethernet 0. The MAC address is here. We have, it can be reachable. This is like for pinging and reachable. You may have to back to respond. Reachable, or sometimes it's called stale. The difference between reachable and stale, reachable, stale means like the device doesn't have mapping between the IP and the MAC in the temporary memory area, which is the cache, for more than 30 seconds. That's it. That's it. So now let's ping again the number 30. And let's run the IP neighbor again. Now we have 2 entries. So let's ping, let me show you this one. Here it is. That's 2 entries. Now I'm gonna ping 192.168.10.40. Unreachable. That's it. That's it. So if you have an IP, yes, you get it. If you don't have an IP, you don't get it. That's it. That's it. We send those for 3 or 4 packets. You can see at the bottom over here, I have sent 3, received nothing, and everything 100% packet loss. And that's the average show for the response. That's it. That's it. That's the whole idea about the ARP and the ping as well. If you need more details about the concept itself, I do encourage you to jump into the video for the lecture video. Now let's go to the task number 2, and that's the real task for today. What we will do in task number 2, we will create a topology which has 3 networks. They require routing. So you have a layer 3 device between, not layer 2 device. Layer 2 device can create you 1 network. We want 3 networks. How we do something like that? Let's add a new project, name it whatever the name we ask you, whatever it is. So that's what routing. Okay, let's call it routing week 6, and put your student ID, whatever it is. Anyway, follow the routing, the naming we ask you to do. What we build here, easy. So let's go for 2 Linux routers, 2 switches, 2 switches, and 4 Linux hosts. Now let's link them together. I'm gonna use 0 here at the bottom, so we can use 0 as well here to the internal network, the ports. And I'm gonna use Ethernet 1 to link both of them. And I will take this one up a little bit. So I want to show you that, yes, like that. So you can see which port or interface the router linked to. We will use 3 different network. I'm gonna use 1.1.1.1.0/24. And this network, I'm gonna use 2.2.2.0/24 as well. And over here, 3.3.3.0/24. For the gateways, I'm gonna put over here .1. Similar, I'm gonna put over here as well .1. Here, I'm gonna put this is .1, and here .2. For the PCs itself, yes, okay, I'm gonna configure this one as .10. This one is .20. That one is dot 30, and that one is dot 40. Now let's configure device per device. So let's jump into the host, since that's the one which is usually the easy part. So here it is. That's host 0. And I need a gateway. Yes. What is the host IP over here? That's 1.1.1.10. And what is the actual gateway? 1.1.1.1. For now, we ask you to put the IP forwarding, and make it equal 0, but it will not affect our pinging. So let's forget about that one for now. So 110, and the gateway is 11. Similar to that, we will go over here and over here that we will take 1.1.1.20, and the gateway is 1. Just remember that, please. Over here, I'm gonna go, this is network tree. Please remember that. What is my IP here? 3.3.3.30. And what is my gateway? 3.3.3.1. Done. Yes, no problem. No problem. With the 40, the same thing. That's the gateway. 3.3.3.1. And over here, 3.3.3.40. We done with the hosts. Now let's go to the routers, because that's the real issue. I have two interfaces for each router. Router interface Ethernet 0, that's the internal network, and the internal host, and over here the external network, which is going to take me to the outside. So let's go over here. This one is one network, that's two network. Let's jump over here, and what's on the interface 0? Okay, so the interface 0, which I remember that's my gateway, that's 1.1.1.1. Okay, I don't have to put anything else. That's only the net sys CTL nets IP version 4.IP underscore forward and make it equal 1. So just review the spelling. IP systel net IP version 4.IP underscore. Yes, that's here it is. I'm gonna copy that because I will need to use that later on. So Ethernet 0 is 1.1.1.1. Now let's jump to the Ethernet 1. That's the one going to the other side. So here it is. I will put this one here. What is the IP address for the Ethernet one here? 2.2.2.1. That's it. That's it. Nothing else. So apply to that. Let's jump to the router number 2, and we will do the same thing exactly. Ethernet 0. What's the IP address for Ethernet 0? That's 3.3.3.1. And I'm going to put the forwarding here as well. And let's jump into the Ethernet 1. Ethernet 1. What is the IP address of the Ethernet 1? 2.2.2.2. And let me put the forwarding. So before we close that, review the IPs. That's router number 2. The Ethernet 1, which is going to the other side, that's 2.2.2.255. The spelling for the forward statement is correct. And here it is. Here, similar to that, before we jump into the configuration, here it is. I'm going to review that. That's 1111 and the forwarding in Ethernet 2.2.2.1, 255, and the spelling as well for the IP version for forwarding. That's it. That's it. Everything seems okay. Now let's turn on the PC, the project, and let's see what we'll do. I'm going to show you how to troubleshoot when you ping and the ping didn't work. How to troubleshoot, how to find out where is the problem. So let's jump in first. I'm going to open that, the 1.1. So can I ping the other side right away? Let's ping the 3.3.3.3.40. Unreachable. Why is unreachable? Okay, how I troubleshoot. Okay, now let's ping your gateway first, which is router 1 first, that interface. So I'm gonna ping 1.1.1.1. Yeah, I can reach 1.1. Okay, if you can reach that, can you reach this one, which is 2.2.2.1? Yeah, okay, let's ping that as well. 2.2.2.1. Yes, I can reach that. So, okay, now ping the next one here. Can you ping to 2.2.2.2? No. So we have a problem that the packet didn't go on the transfer link. Okay, so, right, no, maybe the other side is correct. Maybe this side is the only wrong. No, let's go over here and let's jump into, this is the 40. Okay, the same thing. Let me ping the other side here. Can you ping 1.1.1.10? Unreachable, which means I don't understand it. I don't know anything about that network. Similar. Can you ping your own gateway? Okay, ping 3.3.3.1. Yes, I can ping that. Can I ping 2.2.2.2? Can you ping 2.2.2.2? Yes. Okay. Can you ping 2.2.2.1? No. So where is the problem? Oh, the problem clearly that the packet from both network can reach up to the beginning of the link, but it cannot go through the link. Why is that? Easy, because it needs routing. What type of routing we have? We have static, we have dynamic. And within the static, we have something called as well default. So the one we will focus on today. The default, the dynamic one, we have RIP, we have OSPF, we have ERGP. Maybe you're familiar with one of them, a couple of them in the previous units. I believe that you did, at least one of them. For the static routing, we can specify, can you take that direction or not that direction? Can you take that interface or that not interface? But this one, when we have multi-link to the router, so multi-directions to the router. Here, just only because we have one direction right now, we're going to use the default ones. So it's only one command. I'm going to show you that. You will see that it's really easy. The only thing that I have changed, so this one is Ethernet 1. This one is Ethernet 0. So why is that? Because I link the link between the two routers to Ethernet 1, not 0. So I'm going to change that, but actually that's the command. So what we do, all right, so let me just show you. We go to the router number 1, and let's type over here in router number 1. Can you do IP route? Can you add for me a default routing? And can you take the direction through what? Now through what? I'm here, and I want to send my packet to the other router. Where it gonna go? To here, which is 2.2.2.2. And div, that's Ethernet 1, not 0. In my case, I build the topology as Ethernet 1, which means that here it is, send this one to Ethernet 1, the IP address 2.2.2.2. That's it. That's it. Here it is, done over here. I'll do the same thing with the router number 2. Can you go for IP routes? Add defaults via what? 2.2.2.1, which is this one. Okay, and what is the div? It's over here, Ethernet 1, as you can see that. That's it. That's it. Let's see if our work is accurate or not. I'm gonna go back to the host number. Here it is. It worked actually automatically. Here, let me just stop that. Here it is. Now I'm on host number. Let me close those ones so you guys can see what's here. This is host number 4. Let's go back again and we ping the same one again. Can you ping 1.1.1.10, which is the PC from the other network? Yes. Now I can ping. Can I go through the router? Can I go through? Yes. Let's go to the host number 1, which is this one. That's host number 1. So, which is 1.10. Okay, so host number that 1.10. Can you ping for me 3.3.3.40, 3.3.30? Here it is. Easy as that. One line of command, you tell the router, can you send my packet straightforward to that direction, to that interface, to that IP address. That's lab number 6. I hope that will help you out. Have a good one, and I'll see you in lab number 7. Have a good one.